Hello and welcome to Commissioner of Technical Education and BISEC presented lecture series on subject Applied Mechanics for Diploma second semester students. Myself Hitesh Kanani is going to take a lecture number 4 on unit 5, that is friction. So let's see on slide. In previous lecture, we have seen various examples on equilibrium of body resting on rough inclined plane, where force is applied along the inclined plane. Now, in this lecture, we will study about equilibrium of body on rough inclined plane, but here force is applied horizontally, and example based on it. Let's see first theory of it. Now, as shown in figure, here one block is given on inclined plane. Block is having a weight W. Angle of inclination of this plane is alpha. Normal reaction which is acting from the surface, that is R. Weight which can be resolved in a two part. One is a W cos alpha and one is a W sin alpha. And here force P which is acting horizontally. So we can also resolve this P as a P cos alpha and P sin alpha. Here when the body is just on the point of motion towards down the plane. So in this condition it is assumed that block is moving downward, hence friction is acting upwards. So your friction F is towards the positive direction of plane. For the analysis purpose, consider a block of weight W is kept on an inclined plane having angle of inclination alpha with horizontal as shown in figure. So here alpha is shown here. The block is just at the point of sliding downwards. As the block is just point of sliding downwards, friction is acting upwards. The forces acting on the block which keep it in equilibrium are: first, weight of the block which is W acting downwards, which can be resolved in a W cos alpha and W sin alpha. This angle also becomes alpha, hence it can be W cos alpha and W sin alpha. Second force, that is a applied force P. So here P is applied, which is horizontally applied and which makes an angle. So here is alpha, similarly here also becomes alpha. So we can say that P can be resolved in a two component, that is P cos alpha along the plane and P sin alpha toward the downward side of Y. Third force, that is a frictional force. Now as the block is moving downward, frictional force F is acting upwards along the inclination of plane. And normal reaction from the surface is given here is an incline, and perpendicular to that is reaction R. So normal reaction is capital R. Now resolving the forces perpendicular to the inclined plane. So here is a parallel and here is a perpendicular. So perpendicular forces are upward reaction, that is normal reaction R, downward reaction, that is W cos alpha, and component of P, that is P sin alpha. So three forces there under which equilibrium is there. So perpendicular to the plane, So we can say sigma V is equal to sigma Fy is equal to 0. So R minus W cos alpha minus P sin alpha is equal to 0. R is acting upwards, hence it is taken as a positive. W cos alpha and P sin alpha both are acting towards the negative direction of Y, as here coordinate has been considered as a x direction toward the inclination of plane and y direction normal to the inclination of plane. So we can say R is equal to W cos alpha plus P sin alpha. That becomes our equation number 1. Now resolving the forces parallel to the inclined plane. So parallel to the inclined plane, if we resolve, then there are P cos alpha, which is towards the positive direction of x, F, which is towards the positive direction of x, and W sin alpha, which is negative direction of x. So we can say that P cos alpha and F becomes positive and W sin alpha becomes negative. So resolving, we can say that sigma H is equal to 0 or sigma Fx is equal to 0. P cos alpha, which is positive, W sin alpha, which is negative, and F, which is positive, that equals to 0. So we have a P cos alpha plus F, that equals to W sin alpha. That becomes our equation number 2. Now we know that law of friction, that is F is equal to mu into R, and that value we are putting in an earlier equation. Earlier equation is a P cos alpha plus F is equal to W sin alpha. We are putting a value of F inside it. So P cos alpha plus mu into R, that equals to W sin alpha. But putting value of R, so R already earlier is resolved and found out as a R is equal to W cos alpha plus P sin alpha. That value if we put here, then P cos alpha plus mu into, by putting value of R here, W cos alpha plus P sin alpha, that equals to W sin alpha. Simplifying, we can get P cos alpha plus mu W cos alpha plus mu P sin alpha, that equals to W sin alpha. So again, P cos alpha plus mu W cos alpha plus mu P sin alpha, that equals to W sin alpha. Simplifying this, P cos alpha plus mu P, so P terms on one side and W terms on other side, so P cos alpha plus mu P sin alpha, that equals to W sin alpha minus mu W cos alpha, making common P and W from these two equations. So P is common here, so it results as a cos alpha plus mu sin alpha, that equals to W sin alpha minus mu cos alpha. Now further simplifying, we can get P is equal to W sin alpha minus mu cos alpha divided by, in parenthesis, cos alpha minus mu sin alpha. That becomes our equation number 3. So this is the first case where block is moving downwards. Now take another case where block is moving upwards. So this is the second case when the body is just on the point of motion up the plane. It means block is moving upwards. If block is moving upwards, then friction is acting downwards. So here friction is acting downward. That's the difference between the earlier case and this case. Now resolving the forces perpendicular to the inclined plane. So it is like a earlier case. So R is a normal reaction which is acting perpendicular to the plane. W cos alpha, which is downwards, negative direction of Y. P sin alpha, which is also downwards or a negative direction of Y. So R is taken as a plus, P sin alpha and W cos alpha both are taken as minus. So here we can see that sigma v is equal to 0, sigma fy is equal to 0. R minus w cos alpha minus p sin alpha, that equals to 0. So R is equal to w cos alpha plus p sin alpha, that becomes our equation number 4, which is like equation number 1. Now resolving the forces parallel to the inclined plane, we have a sigma h is equal to 0, that is sigma fx is equal to 0. So there we have a p cos alpha which is acting in a positive direction of x, w sin alpha which is acting towards the negative direction of x, and frictional force F which is also acting negative direction of x. So putting these values, p cos alpha minus w sin alpha minus F, that equals to 0. So p cos alpha, that equals to w sin alpha plus F, so it becomes a equation number 5. But from the law of friction we know that F is equal to mu into capital R. So we can say that p cos alpha, that equals to w sin alpha plus mu R. But putting the value of R in that equation, R is equal to w cos alpha plus p sin alpha. So p cos alpha equals to w sin alpha plus mu w cos alpha plus p sin alpha. By simplifying we can get p cos alpha equals to w sin alpha plus mu w cos alpha plus mu p sin alpha. Putting the p terms on one side and w terms on other side, p cos alpha minus mu p sin alpha, that equals to w sin alpha plus mu w cos alpha. So here this term has been taken on another side, making p common from this two and making w common from this two. So p cos alpha minus mu sin alpha, that equals to w sin alpha plus mu cos alpha, making a p as a main parameter. So we have a p equals to w in parenthesis sin alpha plus mu cos alpha divided by in parenthesis cos alpha minus mu sin alpha. So that becomes our equation number 6. So that way we can analyze force P where it is acting horizontally. Now let's take few example on it. Example number 1. A small block of mass 100 kg is kept in position on a plane inclined at 30 degree to the normal by the application of a horizontal force P. The coefficient of friction of the contact surface is 0.3. Find the maximum and minimum value of P. So here what is given to us in a data? Mass of the block is given, that is 100 kg. Then inclination of the angle, that is 30 degree. Horizontal force, that is P. Coefficient of friction, which is 0.3. And we have to find a P maximum as well as P minimum. So what pull? Maximum and minimum, that we have to obtain in this example. Now given data we can summarize as weight of the block. We have to obtain, here mass is given, so mass is 100 kg. W is equal to mg, that is mass into gravity acceleration. So mass is 100 into gravity acceleration 9.81. So it results as a 981 Newton. Angle of plane with horizontal, that is 30 degree. So here it is. Coefficient of friction mu, that is 0.3. Now there are two cases happen, and there we can get two values of P. One is a maximum one and another is a minimum one. So first case is when the block has a tendency to move down the plane. So it means that this block, under the force of this, it is moving downward the plane. So if it is moving downward, then friction is acting upward. So here in this figure, frictional force is given along the plane upwards. Now as we know, consider a block of weight W, that is 981 Newton. So here W is 981 Newton, is kept on an inclined plane having an angle of inclination. So here angle of inclination given as a 30 degree. So here it is alpha is equal to 30 degree with the horizontal as shown in figure. The block is just at the point of sliding downwards. So here we assume that this block is moving downwards under this force. So if it is moving downward, then frictional force is acting towards the inclination of plane. The forces acting on the block which keep it in equilibrium are weight of the block, that is W is equal to 981 Newton, which is acting downwards and which can be resolved in a two part, that is W cos alpha and W sin alpha. Applied force P. Now this P is also making an angle alpha with inclination or plane. So we can say that it is having angle alpha. So P can also be resolved in a P cos alpha and P sin alpha. Frictional force F acting upward along the plane. As we have considered, this block is moving downward, hence frictional force F is acting along the plane and upward direction. Normal reaction from the surface which is perpendicular to the surface, hence it is R. So these are the parameter and we have to solve for this. Now resolving the forces perpendicular to the inclined plane. So first thing is a perpendicular to the inclined plane. So there R is acting upwards, P sin alpha acting downward, W cos alpha acting downwards. So R is positive, P sin alpha and W cos alpha negative. So putting these values, R minus W cos alpha minus P sin alpha, that equals to 0. Here value of W, that is given in terms of mass 100 kg, that is in terms of weight or Newton 981. So putting these values, W is 981, alpha which is given as a 30 degree, P we have to obtain, so it is unknown, alpha again given as a 30 degree. So putting this value, by simplifying this, R is equal to 849.57 plus 0.5 P, that is equation number 1. Now resolving the forces parallel to the inclined plane. So first we have taken perpendicular to the plane, now towards parallel to the plane. So there three forces are acting. First is the P cos alpha, which is acting towards the positive direction of X, frictional force which is F acting towards positive direction of force, and W sin alpha which is acting towards negative direction of force. So sigma H is equal to sigma Fx is equal to 0. Putting this value, P cos alpha minus W sin alpha plus F, that equals to 0. Now here certain data given to us where W is given to us, so we can put 981, alpha which is given to us, that is 30 degree. So putting there, so it is a P cos 30 minus 981 sin 30 plus F equals to 0. Putting value of cos 30, that is 0.8660, and sin 30 which is 1/2. So multiplying with this, we can get 981 into 1/2, that is 490.5, which is negative. If we put on other side, then it becomes positive. So we are simplifying that, P into 0.8660 plus F, that equals to 490.5. That is our equation number 2. using law of friction, that is F is equal to mu into R. Mu is given to us and R also we have resolved. So F is equal to mu is given as a 0.3 and R earlier calculated, that is 849.5 plus 0.5 P. So putting this value and simplifying it, F result out as 254.85 plus 0.15 P. P into 0.8660, that is earlier equation, plus F is equal to 490.5, that is earlier equation. Here we have a value of F, so we can put here this value. If we are putting here, then equation is P into 0.8660 plus F value, which is from earlier equation, so 254.85 plus 15P, that equals to 490.5. By simplifying, putting P values on one side and other values on other side, 1.016P, that equals to 490.5 minus 254.85. Simplifying this, we can get 1.016P, that equals to 235.65. Further simplifying, P is equal to 235.65 divided by 1.016. That come out as P is equal to 231.94 Newton. So this is a case when friction is also acting upwards as well as force is also acting upwards. So we can say this is the value of P minimum. So whatever value obtained of P is minimum here. So minimum value we can get of P is 231.94 Newton. Now consider another case where value of maximum is required to be obtained. When the block has a tendency to move up the plane, now resolving the forces perpendicular to the inclined plane, sigma V is equal to sigma Fy is equal to 0. Like again, we have a R is acting upwards, P sin alpha and W cos alpha acting downwards, so those two things are minus and R is positive. So R minus W cos alpha minus P sin alpha, that equals to 0. We can say that putting a value of W and alpha in this equation, R is equal to R minus 981 cos 30 minus P sin 30, that equals to 0. So R is equal to 849.57. By multiplying these two we get this, and sin 30, that is 1/2, so it is 0.5 P. So that becomes our equation number 1, and we have found out R in terms of P. Now resolving the forces parallel to the inclined plane. So earlier we have taken perpendicular to plane, now parallel to plane. Three forces there, P cos alpha, W sin alpha and F. P cos alpha acting towards the positive direction, so hence it is positive. W sin alpha and F both are acting opposite to that or towards the negative direction of X, hence it is taken as a minus. So P cos alpha minus W sin alpha minus F, that equals to 0. Putting value of W and alpha in this equation, we have a P cos 30 minus 981 sin 30 minus F equals to 0. Putting value of cos 30 and sin 30, and we can say the sin 30 is nothing but 1/2, so it is a 490.5, which is taken on other side, so it is 490.5, and value of cos 30.8660 into P, F remains as it is, that is becomes a equation number 2. Using law of friction, F is equal to mu into R. Mu value which is given to us, that is 0.3, and value of R which is earlier calculated in terms of P, that we are putting here. So it is a 849.5 plus 0.5 P. Simplifying these two, we can get 254.85 plus 0.15 P. Now earlier equation, after resolution on parallel direction, we have a P 0.8660 minus F, that equals to 490.5. Now we have obtained a value of F and we can put here. So putting that value of F here, P into 0.8660 minus 254.85, that is from here, and when we multiply it is minus, hence here also it is minus, so minus 0.15 P, that equals to 490.5. Then by simplifying 0.716 P, that equals to 490.5 plus 254.85. Again further simplifying 0.716 P, that equals to 745.35. Further, P is equal to 745.35 divided by 0.716. So ultimately we get P is equal to 1040.99, or we can say 1041 Newton. So this value of P, we can say that it is a maximum value to make block in equilibrium. So there are two values of P we obtained. One is a minimum one, second one is a maximum one. So there we have completed that first example. Now let's take another example, example number 2. Calculate horizontal force applied required for a block weighing 20 Newton to push up the plane whose slope is 30 degree. The coefficient of static friction is 0.25. So here in this data, horizontal force P value is required. So P we have to obtain. Block weight, that is given as a 20 Newton. So capital W is a 20 Newton. And slope alpha is given as a 30 degree. The coefficient of static friction, that is mu, that is also given 0.25. So these are the parameters given to us. So let's see solution of this. Given data, weight of the block, that is capital W, which is given as a 20 Newton. Angle of plane with horizontal, that is given as a 30 degree. Coefficient of friction, that is mu, that is given as 0.25 Newton. Now when the block has a tendency to move up the plane, under this force, when the block is moving upwards, then friction is acting downwards. So here in this example, friction we have taken downwards. Weight of the block, that is 20 Newton. Horizontal force is a P. Friction is acting downwards as the block is moving upwards. Angle of inclination, that is 30 degree. Normal reaction is R. So these are the forces, among which we can resolve the weight W into component W cos alpha and W sin alpha. W cos alpha is towards perpendicular to the plane. W sin alpha towards along the direction of plane. P also makes angle alpha, hence we can also resolve in a two component, P cos alpha and P sin alpha. P cos alpha is towards the inclination of plane and P sin alpha is perpendicular to the plane. Now resolving the forces perpendicular to the inclined plane, sigma V, that is a sigma Fy, equals to 0. So there are three forces there. One is a upward reaction R. Two forces which are downward, those are W sin alpha and W cos alpha. So putting this value in this, R minus W cos alpha minus P sin alpha, that equals to 0. So we can say that putting a value of W and alpha inside this, so R minus 20 cos alpha, alpha also given to us, that is 30 degree, and P sin 30, that equals to 0. By simplifying this, we can say, on taking on the other side, R is equal to 17.32 plus 0.5 P. That becomes equation number 1. So we have obtained a value of R in terms of P. Now resolving the forces parallel to the inclined plane. So parallel to the inclined plane, we can see P cos alpha, which is acting towards the positive x-axis, W sin alpha towards the negative x-axis, F, which is also towards the negative x-axis. So 3 forces there, among which P cos alpha is positive, W sin alpha and F both are negative. So putting this value, P cos alpha minus W sin alpha minus F is equal to 0. Putting values of cos alpha and W in this equation, we have alpha as 30 degree, W as 20. So we can say that P cos 30 minus 20 sin 30 minus F equals to 0. P into 0.8660 minus F equals to 10. So taking this 20 sin 30 on other side, we can get this, and putting value of cos 30 here. So that becomes our equation number 2. Using law of friction, that is F is equal to mu into R. F is equal to, now value of mu is given to us, so it is 0.25, and value of R, which is obtained from equation number 1, that is 17.32 plus 0.5 P. In terms of P, we are putting here. By simplifying, we can get F is equal to 4.33 plus 0.125 P. Now when we have resolved these forces along x-axis, we got an equation, that is P into 0.8660 minus F, that equals to 10. So there F is unknown at that time. Now we have obtained F in terms of P. So putting value of F, which is 4.33 plus 0.125 P in this equation, P into 0.8660 minus 4.33 minus 0.125 P, that equals to 10. Further simplifying and deducting P, we can get 0.741 P equals to 10 plus 4.33. Further simplification, we get 0.741 P, that equals to 14.33, or we can say P equals to 14.33 divided by 0.741. Ultimately we get value of P that come out as 19.34 Newton. So here we have solved second example. Let's see third example. Data given in this third example is a body of weight 800 Newton. So capital W is given to us, that is 800 Newton, at an angle 15 degree to the horizontal. So angle of inclination, that is alpha, which is given as a 15 degree. A horizontal force of 360 Newton is just sufficient to cause the body to start moving up the plane. So here condition is also given that upward plane movement is there. So we can say friction is acting towards downwards, and force P is given as 360 Newton. So here required is a mu, coefficient of friction mu is required. So given data in this example, weight of the block, that is 800 Newton, angle of plane with horizontal, that is 15 degree, applied force P, that is 360 Newton, when the block has a tendency move up the plane, so here block is moving upside, then we can say that friction is acting downwards. So here in this figure it is shown with F, and what is given to us, that is a weight W 800 Newton, horizontal pull that is P 360 Newton, alpha which is 15 degree. So those things are given to us. Now resolving the forces perpendicular to the inclined plane. So here is the inclined plane, and perpendicular to that we have a R, P sin alpha, W cos alpha. So three forces that, among which R is acting upward, so it is plus, P sin alpha which is acting downward minus, and W cos alpha which is acting downward, hence it is minus. Putting these values, R minus W cos alpha minus P sin alpha is equal to 0. Putting values of W, that is 800 Newton, and P, that is 360 Newton. Two values given to us, as well as angle alpha also given to us. So putting this here, R minus 800 cos 15 minus 360 sin 15, that equals to 0. Simplifying, R is equal to 772.74 plus 93.17. That results as a 865.91 Newton. So we have obtained value of R, that is normal reaction obtained. Now resolving the forces parallel to the inclined plane. So parallel to the inclined plane we have a P cos alpha, W sin alpha, and F, among which P cos alpha is towards the positive direction of X, W sin alpha and F both are toward negative direction of X. So we can get equation as P cos alpha minus W sin alpha minus F, that equals to 0. Putting values of P and alpha in that equation, that is 360, putting value of P as 360, alpha as 15 and W as 800, 360 cos 15 minus 800 sin 15 minus F equals to 0. Simplifying it, 360 in parenthesis 0.9659 minus 800 in parenthesis 0.2588 minus F equals to 0. Further simplified, 347.724 minus 207.04, putting F on other side, it equals to F. So we obtain value of F, that is friction, as 140.684 Newton. Now we know that law of friction. So law of friction is mu is equal to F upon R, or F is equal to mu into R. So putting in that value of F and R, we have a value of F as 140.684 and value of R as 865.91, and simplifying we can get, so first is a 140.684, that is equal to mu into 865.91, then mu is equal to 140.684 divided by 865.91, which ultimately result as a mu is equal to 0.1625. So this is a example which is solved and value of mu now obtained. In today's lecture we have seen inclined plane on which horizontal force is applied on it and body can move. In first case it is moving downwards, and in a second case body is moving upwards. In next lecture we will see various example by using Lami's theorem. Thank you.